Hello, let's move to problem number 4. So problem number 4 asks you what's the potential difference VB minus VA when a current of half an ampere is in the circuit segment shown in the figure, which is here. So here we are going to use a principle very similar to Kirchhoff's loop law. It's not exactly a loop. We are going to be traversing from B to A. As you can see, this is not exactly a loop, but we are going to use the principles of the Kirchhoff's loop law. The Kirchhoff's loop law tells you how much potential you lose or gain when you go through a resistor or a battery. We are going to use those principles to solve this problem. So please bear with me here. So we start with the Kirchhoff's loop law, and even though it's not quite a loop, I'm going to be going from B to A. So I start from the VB, from the point B, and let us say that the potential of the point B to start with is some VB, and then I'm going to be moving from B to A. So when I do that, when I go from B to A, what's the first thing I see? Well, I see a 16 ohm resistor. So how much potential difference do I lose or gain? Well, you can see that there's a current I moving in the circuit, and it's going through a 16 ohm resistor. So since I'm traveling in the direction of the current, I'll be losing potential. So this is going to be VB minus 16 times I, right? And then what do I see? I see a 15 volt battery. And then am I going positive to negative or negative to positive? You're right, I'm going from the positive end of the battery to the negative end of the battery. So I'll be losing potential. So it will be VB minus 16I minus 15 volts. Again, I'm suppressing the units, not showing the units for convenience. And then what's the next thing I see? 15 volt battery, and then the next component I see is 10 ohm resistor. And through the 10 ohm resistor, as you can see, I'm traveling in the direction of the current, which means that I'm going to be losing potential. So minus 10I, and then finally I arrive at A. So this should be my VA. Right, so but the problem wants you to find out your VB minus VA, right? So I can just rewrite this equation, in which case I find that my VB minus VA is going to be equal to 16I plus 15 volts plus 10 times I, right? So, and you can use the value of I, it's going to be 0.5 amperes. So 16 times 0.5 is going to be 8 volts plus 15 volts plus 10 times 0.5, which is 5. So which means the VB minus VA is going to be 28 volts. Right? So which means, and it's going to be a positive number. As you can see, it's positive 28 volt, which means that your correct answer choice is A.